Good afternoon, everyone, and welcome to part one of ADA in Work Zones. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have. Looking at the handouts section of the GoToWebinar panel, please note also that PDF copies of the course presentations are available for reference. With that, we will go ahead and turn things over to our instructor, Ron Eck, with the West Virginia LTAP Center. Hello.
Hi, Mike. Thank you. Welcome, everyone. As Mike said, I'm Ron Eck with the West Virginia LTAP. I'm joining you today from my home in Morgantown, West Virginia, and we'll be talking about ADA in work zones, or the full title is, as you see on the slide, Applying ADA in Temporary Traffic Control, Building Accessible and Detectable Work Zones. My background is civil engineering. I spent most of my career at West Virginia University on the faculty teaching transportation classes. About 12 years ago, I guess, I retired from the university. I love LTAP, so I continue to stay involved with LTAP and do training like this, do some technical assistance and other activities. And pedestrians and traffic safety are two of my main interests, so this course falls into both of those areas. You see my email address there. If after the class questions or concerns or something come up, feel free to shoot me an email. I'm always glad to try to respond. Before we go on, maybe Mike, if you would put up the first poll question to help give us an idea of who's with us today on the session.
Yes, very good.
Affiliation?
And the poll question is open, and we see the responses starting to arrive already. All right, very good. A few more seconds. And let's share the results. So Ron, 36% said state agency, 32% said local government, 27% said private sector, 0% said educational, and 5% said other.
Okay.
And in the questions box, Curtis wrote MPO.
Okay. Good. So we have a good mix of folks. It's almost evenly distributed between the state, local, and private, and that's good. Hopefully we'll have some good questions, good discussion. Here's an agenda of what we'll talk about today and Thursday. The items in red are what we'll talk about today, and then the black ones underneath that we'll talk about Thursday. Today we'll go through a background and introduction to the topic and to ADA. We'll talk about the basics of the pedestrian access route. We'll talk about accommodating pedestrians in temporary traffic control zones. And then Thursday, we'll talk about accessible and detectable temporary paths. We'll look at some best practices, and then we'll assess some actual temporary traffic control situations, get your thoughts on pluses and minuses of those actual work zones. What I hope you'll get out of the session over the next couple of days is that at the end of the class, you'll be able to recognize the difficulties that pedestrians with disabilities in terms of no or limited vision or mobility limitations encounter in sidewalk and street work zones, and that you'll be able to integrate these pedestrian needs into the design of safe and accessible temporary traffic control. I hope you'll be able to explain the guidelines and regulations that govern accessible temporary traffic control, and mainly that would be PROAG, the Public Rights of Way Accessibility Guidelines, and the Manual on Uniform Traffic Control Devices, as well as, to a lesser extent, the Americans with Disabilities Act Accessibility Guidelines, ADA. I hope also you'll be able to assess a temporary traffic control setup for safety, accessibility, and detectability. And by that, I mean, if you were to go out on the street and see one, maybe set up by your crews or just one that somebody else set up, you'll be able to assess that to see whether it's safe, accessible, and detectable. Or also, if you're reviewing a set of plans for a larger project, that you'll be able to assess those plans, the design of the temporary traffic control for safety, accessibility, and detectability. And then I also hope you'll be able to select and deploy detectable and compliant devices and temporary ramps for an accessible pathway or sidewalk closure that maybe you are setting up or your agency is setting up, and if necessary, reconfigure the pathway surfaces. So that's what I hope you'll get out of the session over the next couple of days. We'll start with the act, I guess, that really, the legislation that generated the need for this topic, and that is the Americans with Disabilities Act, ADA. President H.W. Bush signed it into law in July of 1990, so it's over 30 years old now. It's an equal opportunity law for individuals with disabilities to allow them to access the same programs and services as able-bodied individuals. So in terms of the law, it's actually civil rights law. So it's a little bit different law than maybe those of us in public works are used to dealing with. We're maybe used to dealing with maybe somebody, a motorist, for example, has a crash in a work zone and is injured and might sue the road agency alleging some deficiency in the work zone. And that's tort law. ADA falls under civil rights law, so it's a different branch of the law. But still, it's important to note it is a liability exposure for state and local governments who deal with the public right-of-way. The United States Department of Justice, the acronym, of course, DOJ, they have the ultimate compliance responsibility. And it's important to note that all programs and new and altered facilities, regardless of the funding source, must be accessible. And notice I highlighted there altered, because if you think about it, to me, that's really what a temporary traffic control area is, right? Would everybody agree with that? That we're maybe narrowing the width of the walkway due to some construction or maintenance or utility work, or we're shifting the path that pedestrians take, or maybe we're detouring them to the other side of the street because the sidewalk is closed. So we're basically, in our temporary traffic control zones, we're altering facilities. And so the key thing is we have to make these temporary traffic control zones accessible and detectable. And that's what we're here to talk about this week. ADA, of course, as you all know, is very comprehensive and addresses a lot of topics. We're going to focus on Title II, which deals with state and local governments. It's probably fair to say that everybody who's here is either with a state or local government or MPO type agency, or if you're with the private sector, whether you're a consultant or a contractor, I'm sure you do work for or with state or local government. So that should be the topic of interest to everybody here today when it comes to the public right-of-way. But even Title II has a lot of different parts to it. But we're going to focus on this class today on subpart D, which deals with program accessibility. And one thing to note, if you're not familiar with the ADA and the law, when you see the word program in ADA, that not only means programs and services, say, of a state government or a city or a county or a town, but program also means the sidewalks and streets. So when you see the word program, that also includes sidewalks and streets. And then subpart E, which deals with communications. So let's look briefly at each of these. Subpart D, program accessibility, says each facility altered by, on behalf of, or for the use of a public entity, meaning a state or local government, shall, notice the word shall there, so it's a requirement, shall to the maximum extent feasible be altered in such a manner that the altered portion of the facility is readily accessible to and usable by individuals with disabilities. So again, when you see altered, think work zone. We're changing the sidewalk or changing the crosswalk because of some construction or maintenance activity. So that new, maybe it's just a temporary sidewalk, but that temporary sidewalk, temporary path needs to be accessible to and usable by individuals with disabilities. I mentioned subpart E, communications. Notice it says a public entity shall take appropriate steps to ensure that communications with applicants, participants, and members of the public with disabilities are as effective as communications with others, meaning able-bodied, sighted individuals. And we'll talk a fair amount about this over the next day or two. So these are the key parts, subpart D and subpart E. Some other terms you'll come into contact with or that we'll talk about, I mentioned this one already, ADAG, the Americans with Disabilities Act Accessibility Guidelines, also referred to as the 2010 ADA Design Standards. It is the current law with respect to ADA. It is the law. However, as the slide says, it's intended for buildings and on-site facilities. In fact, if you look at ADAG, I don't even think anywhere in ADAG does it even mention work zones or temporary traffic control. It doesn't address many of the issues that are in the public right-of-way. It doesn't address roundabouts, for example. It doesn't address accessible pedestrian signals. It doesn't address on-street parking. But there are some parts of ADAG that do apply to the topic here we're talking about, mainly when it comes to, for example, strength requirements of handrails and that sort of thing. To deal with the public right-of-way accessibility issues, the Access Board, which is the federal agency responsible for developing these criteria, they issued in 2002 the first edition of PROAG, the Public Rights-of-Way Accessibility Guidelines. It's a standalone document that gives accessibility standards specific to the public right-of-way, and it's applicable to new construction and alterations. The thing about PROAG is it has not yet been signed into law. It's still in a draft form, or you see there the 2011 NPRM, that stands for Notice of Proposed Rulemaking. So it's still kind of in the draft form. But the recommendation of the DOJ and the US DOT, you see their logos there, their recommendation is that agencies should be using PROAG, and that's my recommendation as well. And also actually the courts, due to their decisions over the last few years, they are also saying that we need to be using PROAG. So this session today and on Thursday will be based on, in part, on PROAG. And for example, here's what PROAG says. There's an advisory about temporary routes. Temporary routes are alterations, which we've already said, to an existing developed pedestrian environment and are required to achieve the maximum accessibility feasible under existing conditions. You might keep that in mind because that's sort of the bottom line. If someone, say a citizen or a visitor to your town or someone would file an ADA lawsuit, a civil rights lawsuit, and the Department of Justice came in to investigate, this is sort of the bottom line they'd be looking for. Has the agency achieved the maximum accessibility feasible under existing conditions? And what you see in this image, I took this photo a few years ago before COVID in New England. I won't mention the state, but it's a New England state. And this may be an example of maybe lack of training on the part of, I don't know if it was a contractor crew or municipal crew who did this, but they may have thought they were doing the right thing by putting these pallets in here to create a step down from the sidewalk to the area where the new sidewalk will eventually go. It's been obviously excavated now, but that is clearly not accessible to someone in a wheelchair, probably not accessible to someone using a walker. And if you look closely, it looks like maybe some of the formwork there, that board from the formwork is sticking up and actually maybe creating a tripping hazard for able-bodied pedestrians as well. So this is clearly a violation of what we've just been talking about. PROAG also mentions what they call the alternate pedestrian access route. And there's a lot of text on this slide. I'm not going to read all of that. But the thing I'd like you to take away from this is notice PROAG refers to maybe half a dozen or more sections of the manual and uniform traffic control devices in terms of barriers and channelizing devices and characteristics of the alternate pedestrian access route. So as I mentioned earlier, in this particular topic, both PROAG and the MUTCD kind of go hand in hand, and we need to be familiar with the provisions of both of them. Many of you are probably already familiar with Part 6 of the MUTCD. And right up front in section 6A.01, it talks about the needs and control of all road users, which includes pedestrians, and including, notice they specifically call out, including pedestrians with disabilities, through a temporary traffic control zone shall be an essential part of highway construction, utility work, maintenance, operations. So it's not just a nice thing to do. The MUTCD has it as a shall condition. So it's a standard or a required situation, required condition. Now, I apologize for these photos not matching up. I originally just tried to take the photo on the right, and I didn't envision that I'd be taking two photos, but let me get my cursor here, my pointer. This is, some of you may recognize it, this is Canal Street in New Orleans, Louisiana. Obviously, New Orleans, a popular tourist destination. Canal Street is one of the probably more popular tourist areas. The street is lined with high-rise hotels. You can see one or two in the background. Behind the buildings on the left is the famous French Quarter. So this is very near the tourist area of New Orleans. You can see the Canal Street is multi-lane in each direction, has a fairly wide median. And in fact, in the median, the streetcars operate. The sidewalks are fairly wide. You can see their aesthetic enhancements in terms of it looks like pavers or stamped concrete. But anyway, I was there for a conference and got up early and was taking some photographs like I normally do. And what struck me originally, the reason I stopped and took this right photo is notice that, in fact, this doesn't even look like a public works project. This looks like some sort of building construction or vertical construction, we might call it. Doesn't really have anything to do with the roadways, other than notice it looks like some construction materials are stored in what had been the parking lane, and it looks like some of the contractors' vehicles are parked along the roadway. And what struck me as an ADA person is this yellow caution tape, which was identifying or maybe supposedly closing off the sidewalk here due to that construction. But as we'll talk about, and hopefully everybody knows, this yellow caution tape is not an appropriate delineator or barricade for a construction or work area because it's not detectable by someone using a cane, by a blind person using a cane. And so that struck me. And as I was taking this photograph and kind of taking in the scene there, the woman that you see on the left, in the left image, came past me, and she stepped off the curb here. And keep that in mind too, because she's an able-bodied pedestrian, or at least appeared to be. Someone in a wheelchair, for example, would not be able to just step off the curb there. If they encountered this yellow caution tape here in the middle of the block, they'd have to turn around and take their chair back to the corner and probably cross the street to the other side, or use the median that you see there in the middle of Canal Street. And so if they're in a manual wheelchair, they've just kind of wasted a lot of energy coming to this point and then having to turn around and go back to the corner. But the other thing to notice it appears that she's about to round the corner here at this tubular marker, and she will be in one of the traffic lanes on Canal Street with her back to traffic. And I would argue that's not a very safe situation, even for an able-bodied pedestrian. But that's the situation here. A blind individual, if they encounter this, they probably encounter it or realize it when this caution tape struck them in the upper torso. But they would have to try to figure out what's going on. And probably, just as I said, for someone with a mobility impairment, probably have to turn around and go back to the corner and try to figure out an alternate route around this work area. So I would contend this is neither detectable nor accessible, and there's no alternate pedestrian access route. So what we'll talk about over the next couple days are the requirements that apply to all temporary traffic control zones by state and local road agencies, by construction and maintenance contractors, both road construction and vertical construction, utility companies, landscape companies, anybody sort of doing this sort of work, as well as any sidewalk, lane, or road closures for vertical construction activities. And that includes things that we've already talked about: closing a sidewalk for repairs or utility work, closing a sidewalk for building maintenance, maybe small projects like a downtown storefront alteration, reconfiguration, something like that adjacent to the public right-of-way, where maybe all or part of the sidewalk will have to be closed for that project. And then major projects, which it appeared this project I just showed you on Canal Street in New Orleans was, where you're going to have long-term closure of sidewalks or road or street lanes. Before we go on, I probably should define a couple terms. I've used the term accessible and detectable a good bit already. Accessible describes an alternate pedestrian pathway through a sidewalk work zone that pedestrians can safely reach and enter and travel through to the end of the work zone. So that implies curb ramps, a smooth, stable, slip-resistant surface, sufficient width that they can turn. And this is not really a work zone in the image you see down here, but notice this sidewalk is a smooth, stable, slip-resistant surface. It's wide enough that it looks like at a curb ramp, for example, this individual would be able to turn his power chair there, a motorized chair, into or onto a curb ramp. So this would be an example of an accessible facility. I've also used the term detectable. What do I mean by detectable? Detectable means a traffic control device placed within a temporary pedestrian pathway that has a continuous edge. And pedestrians with limited vision can follow that edge either by hand or by a navigation aid, what's called the long cane or the white cane. And this is just a static photo, obviously, but the woman in this image who is blind, she is swinging this cane in an arc in front of her, probably go 2 to 3 feet kind of in width, and periodically touching the ground, other times maybe not touching the ground. But what she and others who are blind are looking for would be what they call a shoreline, some edge, a detectable edge that they can follow and maintain a reasonably straight line. And this also is not a work area, but notice this, what would we call this? A little wall here of some sort or high curb. That is detectable with the cane, and she can detect that with her cane. And for her, that would be a good shoreline. She can stay pretty parallel to that detectable edge as long as it exists. So that's what we mean by detectability. And we'll look at some other examples specific to work areas as we go along. Here are some examples. Is this accessible or detectable? I took this in Maryland a few years ago. Can see that it looks like construction is at the block in the distance here. And actually at this point, it looks more like road construction as opposed to sidewalk. At one point, the sidewalk was closed, but it looks now like the sidewalk is open. But notice, it looks like they want pedestrians to cross mid-block. It appears they put in a temporary mid-block crosswalk here. It's marked. And so pedestrians are to cross here to the other side of the street. But how about this sign? Is that detectable to a blind pedestrian? And of course, the answer is no. A blind pedestrian, like the individual we just saw in the previous slide, she's just going to walk right on down that sidewalk to the corner and probably continue on, because she has no way of knowing, since she can't see, she has no way of knowing this sign exists here. So if we're going to close a sidewalk and have an alternate route, we need to have some detectable barricade here so that the pedestrian knows the sidewalk doesn't continue at that point. Well, how about accessibility? Well, no, if I'm in a wheelchair, first thing I notice is I'd have to turn to the left here across this earth material, which is not accessible. It might be accessible on the day this photo was taken. It looks like maybe the sun, has baked that ground, so it's kind of hard. But if it were to rain overnight or rain later in the day or something, that may turn into a mud hole, and so that is not accessible. It needs to be at all times an accessible surface. But even if there was a strip of concrete in here that I could get my wheelchair on, notice there's no curb ramp here. So I have no way to reach the street either. There needs to be a curb ramp here so I can get from the sidewalk to the street. So sadly, this portion of this work area is neither accessible nor detectable. Here's a photo I took in the upper Midwest a couple years ago. A lot going on here. Notice a lot of signing for temporary traffic control signing for vehicles, also for pedestrians, also for bicycles here. So this could be potentially confusing to all of those users. Is this detectable? Notice there's a sidewalk closed sign, which I, as a sighted pedestrian, can of course read that, but remember, a blind pedestrian can't see that. And they would probably have trouble figuring out what's going on here because there's no real barricade with a toe board or kick plate or edge at the ground level that they can use for guidance. Looks like a type 3 barricade here, but that's several inches off the ground. That's not really a detectable edge. So probably what should have been done here for the visually impaired is actually to close this sidewalk at the beginning of the block, behind where I took this photograph, so that the visually impaired don't even get into this area. So even myself, I can see there is a pedestrian ahead of me and she's headed toward the crosswalk, but if that person wasn't there to kind of give me a cue, I'm, as a sighted able-bodied pedestrian, might have difficulty figuring out where to go. And then, is it accessible? Well, notice there's a pipe here kind of in the gutter, and this driveway is, I guess, the main access to the job site. And so the contractor apparently put some pea gravel here so vehicles could go over that pipe. But this loose pea gravel or stone would be not traversable by someone in a wheelchair. So this is not an accessible path for someone in a wheelchair or someone using a walker. So again, this is neither accessible nor detectable. How about this? This is obviously kind of a smaller scale project, maybe short-term duration. Can you see there's a manhole cover here? I can tell you there's a crew of 2 people down below the sidewalk. There was a third individual sort of standing watch here most of the time I was here, but when I snapped the photo, obviously he's not there. Hopefully he's not too far away. But what do we think of this? Well, notice they did attempt to make this opening detectable with this pipe arrangement on the cones. I commend them for that. I would have moved things farther away from the opening than that, I think. But at least they did attempt to make it detectable. As I said, for most of the time I was there, they had an individual standing here. And actually a human can be a good form of traffic control on sidewalk work zones, because that person, if they spot a visually impaired individual, they could provide assistance in terms of the proper path. And it looks like from the curb here to the cone, I'm just estimating, that looks like maybe 5 to 6 feet. So certainly there's an accessible path here. It's a wide enough path that someone in a wheelchair or using another walking aid would be able to negotiate the sidewalk. They may have to go around those cones, but they could still utilize the sidewalk. Why is this important? Well, everybody benefits, even the able-bodied pedestrians benefit from these things we're talking about. But also the United States has a significant disability population. Overall in the population, it's around 10.4%. So in other words, about 1 out of every 10 Americans has a disability. Some of us may, from time to time, have temporary disabilities. Maybe you've had a sports injury or knee surgery or hip replacement or something, and maybe you were using crutches or a walker or even in a wheelchair temporarily. And so it's important for the temporarily disabled that we make things accessible as well. Many communities, of course, want to encourage visitors for economic development reasons. Where I am right now, Morgantown, West Virginia, we like to bill ourselves as kind of a retirement community. You know, come here and live, have a good quality of life. There's a university in the city. You can take advantage of cultural activities, sporting events, and so forth. And if you're going to do that, which is a good thing, keep in mind that when it comes to, say, the over 65 proportion of the population, I think like around 33% of senior citizens are disabled, have some sort of disability. And so, of course, these things are particularly important for the older population. It's also the law, as I've mentioned, that if we don't comply with these things, our agency could be exposed to civil rights lawsuits. But there's also, as I think I've mentioned, safety implications. People can trip and fall or be struck by a vehicle or something and be injured, and then they may file a tort claim in court. And so that's another liability exposure. And I notice the slide is prompting me for our next poll. And Mike, if you wouldn't mind putting up the second poll question.
Sure.
And this is for public agencies only.
All right, and the poll question is open. And we see
just looking at
results.
work area accessibility here, not personal injury type of claims, but just accessibility claims. And I realize some of you may not be in a position to know whether your agency has received complaints or lawsuits, and that's fine. You can just indicate you don't know.
All right, the results are arriving. And we'll give a few more seconds. Okay. And here's the results. Ron, 21% said yes, 25% said no, and 54% said don't know.
Okay. Interesting results, but it seems like 21% indicated there are complaints or lawsuits. So that is, to me, a significant number, which in fact may account for why you're here today. But I don't mean that to scare anybody, but just keep that in mind as well. If we don't comply, there is also that legal exposure that exists as well. Did want to say just a few words before we get into kind of the more technical details, few words about the challenges faced by pedestrians with disabilities. And we'll look at three broad categories. The first one being visual impairments, then mobility impairments, and finally cognitive impairments. And think about the types of issues a blind pedestrian would face in or at a work zone. They don't know if the temporary traffic control is there until they reach it because they can't see maybe any advanced signing that might exist. They don't know if there's a safe alternative way to proceed, or is it like the Canal Street example I showed you where the pedestrians are sort of on their own to figure out how to get around that work site. They don't know if they should attempt to cross the street and walk on the other side or retrace their steps and use some other route. They don't know if a cane can provide a safe way to continue through the detour. And also not knowing if the barriers have exposed nails or jagged edges that can injure someone. As we'll talk about, one of the ways the visually impaired get through a work area sometimes is what they call hand trailing, meaning they'll trail their hand along the top of a barrier or railing to give them the guidance of the path. But of course, if you or I do that, and maybe many of us have done that, we can see if there's a rough surface with maybe splintered wood or exposed nails. But remember, the blind cannot do that. So they're kind of depending on whoever erected that barrier or that railing, that surface is free of any of these hazards that could injure someone. What about issues faced by the mobility impaired? Could be that temporary ramps are too steep or not wide enough for turning. It could be wobbly, may not have an adequate side guard. The ramps or pathways maybe have inadequate bottom protection, where you may have mud or debris or water at the base of a curb ramp, for example. So these are some of the issues faced by those with disabilities. Let's look first at the mobility disabilities. These individuals have limited agility, maybe balance issues. They may travel more slowly, may have limited endurance. So they may appreciate a place to sit down or something to lean onto. And they benefit from firm level surfaces, adequate width, curb ramps like you see in the image here so they can move between the sidewalk and street, and limited cross slope. And again, this is one of those things that this really benefits everybody. A mom or dad pushing a stroller on a city street or residential area benefits from these same characteristics, or a delivery person using a wheeled cart to deliver to a store or a business. They also benefit. Pedestrians with vision disabilities get their information from sounds and textures and contrasts. And we can't hear it here, but in this image, this is what's called APS, an accessible pedestrian signal. It has an audible locator tone to let the visually impaired individual know that there's a push button here. And if they home in on that tone, they can find the push button. And then when the walk indication comes up, that tone, the rate of that tone changes to become more rapid. But if we just look at some of the static features that are here, notice above the push button is a raised arrow. This is called a tactile arrow, and it's lined up with the crosswalk and points in the direction of the crosswalk to help a blind individual get lined up properly. But notice kind of on top of that is a bold white arrow on that dark background. That's what we mean by contrast. And that arrow would help a low vision pedestrian who's not legally blind, but they can't see detail, but they can probably see that color contrast and that bold arrow, and that helps them get lined up with the crosswalk. And then of course we can't see it, but there'd be a curb ramp here with detectable warnings. That's what we mean by a tactile indication of the boundary between the sidewalk and the street. And then this individual, who we can't really see other than their hand, is someone who has a vision and hearing deficiency, and they are taught in orientation and mobility school, or O&M training. They are taught that if they keep their hand on that push button, when the walk indication comes up, that surface will vibrate. That's what we mean by vibrotactile, and that's their indication that the walk sign is on. Individuals with vision disabilities experience what are called information barriers, and here's one of those. Again, the ubiquitous yellow tape kind of delineating this work area. And again, this looks like a building construction project, not really a public works or road project, but this is not a detectable work area. The individual who's blind using the cane will actually walk into that yellow tape before they realize what's going on. And in this case, you might argue, well, that's no big deal because there's just more concrete sidewalk behind the tape. But imagine if there was an open trench just behind the tape, or if there was freshly placed concrete here, that would not be a good situation. Plus, this doesn't really give a detectable edge to help the visually impaired find the alternate access route here under the scaffolding. And then the third category of pedestrians we'll talk about with disabilities are those with cognitive disabilities, meaning disabilities that affect information processing and decision making. Examples are individuals who've suffered a traumatic brain injury, either maybe some of our veterans in the wars overseas, or even individuals who are in a serious automobile crash, motor vehicle crash. They can and do experience traumatic brain injuries. Autism is another example of a cognitive disability. These are challenging to design for because there's so much variety in the types of cognitive impairments, but you see here a few kind of rules that as much as we can, we should try to keep in mind to accommodate the cognitively impaired. So any questions on that introductory material? If you do, just put it in the chat and Mike will interrupt me. Mike, any questions so far that might have come in?
Ron, there's a question from Asia who says, in this case, should cones be there instead of the yellow tape? Should cones be put there instead of the yellow tape?
Asia, I assume you mean this image here, or maybe the other one that had yellow tape. I would say no, because cones do not form, even though the bases may be touching one another, and it may be kind of a continuous line of cones, that the base of those cones side by side do not form a detectable edge. Really, what needs to be done is some sort of I'm just looking here on this image. I see, I don't know if that's one or more sheets of plywood there, but even if we erected the plywood across here, that would be a good detectable barrier. And probably from sort of a safety standpoint, it might be better too, because that way it would kind of be positive, in my mind, more sort of positive separation, or at least separation between the pedestrians and the work area. Yeah, some people ask sometimes, what if they put these drums, orange and white drums, you know, a line of them butting up against one another. That would be better than what's here, but I would say that's still not as good as having kind of a continuous detectable edge, like maybe some lumber here or plywood or something like that, that creates a detectable edge. But good question.
Thanks, Ron. We have a few others, actually.
Okay.
Eli says his contractor claims orange snow fence meets ADA requirements, but how detectable to a cane are they?
Good question. Can I delay answering that for a little bit? We will talk about that. It
Okay.
might be next time, but we will talk about that, of how to make that detectable.
All right, next question from Thomas. Where does an individual with limited mobility or steadiness, say due to age, fit into ADA? Does MUTCD section 6A.01 cover this situation?
I would say yes, although you're right. This is one of those gray areas where they're not specifically identified. But I know my dad, he was always an avid walker, but in the later years of his life, when he got into his late 80s and early 90s, he would still go walking, and I'd walk with him occasionally when I was in town with him. But yeah, I think I know what you're saying there, that he didn't consider himself disabled, but if he got on a sidewalk that had a steep cross slope, his balance had been affected or deteriorated due to his age, that he would almost fall over. Sometimes I have to reach out and grab him. Or, after he'd walk a few blocks, again, just because of his age and sort of lack of endurance, he would appreciate a place to kind of sit down, or if nothing else, maybe a railing to sort of lean against. And yeah, there's really nothing specific in the PROAG or ADAG that really talks about that. But in my mind, that is another group of folks that we have to be aware of that are using our facilities. And so that's why, for example, things like railings are so important. Also why, for example, cross slope is so important, making sure we stay within the cross slope limits.
Thanks, Ron. We have a question. Do the temporary ramps need the raised domes on them?
Another good question. We'll talk about that Thursday. So can I delay answering that one until Thursday? We will
Yep,
talk about that.
absolutely. And in response to one other question, just a reminder to our audience, the PDF copy of today's presentation is available in the handout section of the GoToWebinar panel. So please feel free to download that or copy that at any time. We do have a question from Gary who says, I realize that this work is necessary, but what type of project lifespan are we looking at to apply this to the project?
As I think I'll talk about in a few minutes here, really anything probably from maybe a few minutes to an hour or two up to a multi-year project. If it affects the path of travel for pedestrians, or maybe affects their safety, then these things do need to be implemented as appropriate. And we'll give some examples of that.
All right, thanks, Ron. Those are all the questions at this time.
Okay, great. All good questions. Thank you. Let's look, before we get into the details of some of the things that you all are asking about, let's look at the basics of the pedestrian access route. And this comes from PROAG. But remember, if we're required to have an accessible pedestrian route, alternate route, we need to know what makes something accessible. So that's what we're going to spend a few minutes talking about. So we're going to look at things like width and grade and cross slope and surfaces and what are called protruding objects. And where do these apply? It applies to walkways, so sidewalks, of course, plazas that you might have, ramps, which are just a general kind of ramp, but also specifically to curb ramps, which are a specific type of ramp, and the landings. Something called blended transitions, crosswalks. Crosswalks are part of the PAR, and also pedestrian overpasses and underpasses. Many of you probably have these in your communities. They also have to comply with the PAR requirements. Width. PROAG says the minimum continuous unobstructed clear width of the PAR shall be 4 feet measured from the back of the curb. And this is what PROAG says. I realize some of your agencies, some of you that are in the audience, probably have adopted maybe 5 feet as the minimum width. And that's great. You've gone above and beyond PROAG. But so keep in mind, if your agency has adopted something better than PROAG, that's your standard. But PROAG calls for 4 feet. But I know many agencies call for 5 feet. Just as some examples, 3 feet for one wheelchair user. And interestingly, I mentioned ADAG at the start. The design user in ADAG is an individual in a wheelchair. And so in ADAG, the minimum width of a walkway, travelway is 3 feet, but it's 4 feet in PROAG because the design user is an individual like this, someone on crutches or using braces or a walker. And I think if we measured from crutch tip to crutch tip on this fellow's crutches, that would probably be closer to 3.5 or 4 feet. And so that's why PROAG has a wider minimum width than ADAG. How about this? I took this a few years ago, and I think in fairness, this was not a completed installation yet, although I was a bit troubled. This was evening, you can see lights on there. I was going back to my hotel after dinner, and I noticed this, and I'm a bit troubled that apparently they're going to leave this framework up here overnight with no sort of barricades or anything. So to me, that's a safety issue. And you can see the alternate pedestrian route here. Again, it's not finished. They're probably going to put some boards here or something. I hope to provide, you know, kind of canopy protection. But the things that did sort of trouble me were, notice here, there's a bike rack in the alternate pedestrian access route, which as long as there's no bicycle there, that may be okay. But if there's a bike tied up to that rack, that's going to be an issue. And also notice it's hard for somebody maybe in a wheelchair to get lined up to use that alternate path because there's a water fountain here. There's a non-compliant grate here with large openings that the small front wheel of a wheelchair could drop into. And so there are some detail issues with this arrangement here. If your pedestrian access route is less than 5 feet in clear width, you have to provide passing spaces, 5 foot by 5 foot passing spaces every 200 feet. We should also be aware of what are called protruding objects. Protruding objects are things that project or protrude more than 4 inches into a pedestrian path at a height above 27 inches and less than 80 inches. And here's a classic example of a protruding object, this fire department connection. I don't know if you're like me, I'm a sighted pedestrian, but I've skinned more than one knee on these fire department connections that were sticking out of a, the wall of a building or something. Other examples are tree limbs, signs, pole-mounted traffic signal controller boxes, hanging baskets of flowers, anything that protrudes more than 4 inches into the pedestrian path at a height above 27 inches and lower than 80 inches is a protruding object because it cannot be detected with the cane. If it's lower than 27 inches, it's detectable. If it's above 27 inches, it's not detectable. And these requirements apply across the entire width of the pedestrian circulation path because they're a safety issue. Somebody could poke their eye out on a tree limb or be injured by striking the fire department connection or one of these other protruding objects. Walkway cross slope, one of maybe the biggest challenges within PROAG. Notice the cross slope of the walkway of the pedestrian access route shall be required, shall be 2% maximum. I underline maximum because there is no allowance for construction tolerance. So if your concrete crews or if your contractor says the best I can do is plus or minus 0.5%, then we need to be designing the walkway for 1.5% so that when it's built, it won't be more than 2%. And the reason for this strict requirement is the individuals in the manual wheelchair. It takes a lot more effort to keep a straight line on a steeply cross-sloped surface than on a more level surface. And I think I just mentioned that. Here's a potential solution. Notice the PAR does not have to be the full width of the pedestrian circulation path or the sidewalk. Note in this case, we made the level When I say level, I mean 2% cross slope or less. We made the level portion, say 6 feet wide or 5 feet wide or even 4 feet. But notice the rest of the sidewalk is more steeply sloped. And that has its own issues, but this would be a compliant sidewalk from the standpoint of cross slope. Grade. If the sidewalk is in the right of way and along the road, follows the road, then the sidewalk grade can follow the roadway grade, no matter how steep it is. But if the sidewalk does not serve the street, does not follow the street, then the maximum sidewalk grade is 5%. Also, something else to keep in mind, and we kind of see it in the cartoon drawing down here. Let's imagine this individual's crossing the street. They went down the curb ramp and now they're going up the street crown to cross the street. The maximum crosswalk grade is 5%. So that means the maximum street crown is 5%. Remember what I said earlier, crosswalks are part of the pedestrian access route, so they have to comply with these requirements. In terms of a manual wheelchair, obviously it takes a lot more energy to go uphill, more tiring than downhill, but actually, to me, downhill is probably the more critical situation. It's maybe difficult to control the speed of the wheelchair. That's why this fellow is wearing gloves in the summertime to avoid, blistering or peeling the skin off his hands trying to brake the wheelchair. But also people using crutches or walkers or canes, it's harder for them to go downhill because it may be difficult to kind of maintain stability, balance, and control, and there's a greater danger of them falling. A real cross slope challenge is driveways. The grade of the driveway becomes the cross slope of the sidewalk. And it's like a West Virginia driveway. Most of our driveways are far steeper than 2%. And so then it becomes a non-compliant sidewalk cross slope. But another issue is the grade breaks here, where the sidewalk meets the driveway. And I realize this is a cartoon depiction, but it's technically accurate. If you look closely, notice the small front wheel of that wheelchair is off the ground. And any time that happens, that's not a good thing because the stability of that wheelchair is jeopardized. That chair could tip over or flip over. So we want our routes, our designs to be such that all 4 wheels of a manual wheelchair are always on the ground at all times. Surfaces, PROAG says they must be firm, stable, and slip resistant, and they should be smooth. So the best surfaces would be, for example, concrete or asphalt, timber, like a boardwalk. That's firm and stable, may not be so slip resistant when it's wet, so we may need to do something to increase the friction or slip resistance. Same thing with steel plates. Sometimes I've seen agencies put a steel plate over, say, a trench in the sidewalk, and that's fine as long as there's a way to get onto and off of that plate, but also there should be some slip resistance on that plate as well, because metal, of course, or steel can get slippery when wet. We do need to pay attention to vertical alignment. This is not a good situation. This shows kind of a double jeopardy here. An agency could face an ADA civil rights lawsuit here because this would be not traversable by a wheelchair. But also if an able-bodied pedestrian tripped and fell here, they might be subject to, the agency might be subject to a personal injury lawsuit as well. And I think we just talked about that. Notice how this stops the manual wheelchair. And depending on the speed of the chair, that abrupt stop could actually pitch the person in the chair out of the chair onto the sidewalk. So PROAG does have guidance for vertical surface discontinuities. They cannot exceed a 1/2 inch maximum. And those between 1/4 and a 1/2 inch need to be beveled with a slope not steeper than 50%. or 2 to 1 over here on the right. So we could do that. We could put in a wedge of concrete here. That would be one way to get that ramping or beveling. Or if it's a concrete sidewalk, we could grind the upper slab at that 2 to 1 or 50% slope across the entire vertical surface discontinuity. Here's another example. This is not the same site in both images, but it shows kind of the same problem. Notice here on the left, I guess maybe they're pumping concrete or something. And notice this hose along the or across the sidewalk. Obviously, that's sort of a safety hazard as well as a accessibility issue. Someone can't get through there unless they're able to kind of step or jump over that hose. So here on the right, you see a potential solution to that issue of the large hose across the sidewalk or across the walkway. And I raise the issue, what do you think? And to give you a chance to respond, we have a poll question. So Mike, if you put up the third poll question, and this is our last poll question for today.
Yes. And the poll question is open.
But what do you think? What you see in the right there, does that look good? No issues? Is the ramp too steep? Is the ramp too steep and the surface too slick? Or should that arrangement be orange in color?
All right, and we have some responses arriving already. And we will give a few more seconds. Okay. And we'll share the results. So Ron, 2% said A, 31% said B, 66% said C, and 1% said D.
Okay, good work. Yeah, most of you, about 2/3 said the ramp is too steep and the surface is slick. And in my opinion, that's the correct answer. Obviously, it looks, to me, this looks steeper than 50% or 2 to 1. And if we look closely, it looks like this is just sort of enamel paint on this ramp arrangement here, some sort of metal ramp arrangement. And actually, this would probably be maybe slick even in dry weather, but especially when it gets wet, that will become very slick. So the correct answer is C. The ramp is too steep and the surface is too slick. So how about, this is not the same location, but how about something like this? Notice it's a gradual ramp up to the pipe and then a ramp down. It looks like they've painted the plywood with an abrasive type of paint with some grit in it. They've put in a transition here at the base of the ramp to allow smooth movement over the edge of that plywood. They even have a railing system. The top rail should be at 32 inches. And maybe there is a rail up there, but I don't really see it. If you're going to have a rail, to me, it needs to extend the full width or full length of that ramp. So that's one issue. The other issue I have is, what about the visually impaired? To me, there should be some sort of barricades or edging here on both sides to prevent the visually impaired from getting off to the side here. And certainly they could detect these sandbags and all the plumbing and piping that's going on there. But to me, the issue would be, could they figure out what the heck's going on? So it would be better to have some edging to kind of, or barricades or channelizers to kind of funnel them to the ramp itself. So to me, this is a better, much better solution than the one I showed you on the previous slide. Also need to be alert to joints in the walkway and gratings, because as you can see, the small front wheels of the wheelchair can drop into that, causing immediate stopping of the chair, or somebody's crutch tip or cane tip could drop into an opening. And so not only the width of the openings, but also the orientation of the openings is important. Curb ramps, I mentioned curb ramps. We'll probably go through this kind of quickly, but curb ramps address what I call the curb ramp conundrum. Curbs are a good thing for the visually impaired. They create a shoreline. And so a blind pedestrian with a cane can follow the curb. However, if I'm in a wheelchair, those curbs are not a good thing because they're a barrier. They prevent me from moving between the sidewalk and the street. So we put in curb ramps to remove that barrier, but then for the width of the ramp, there is no curb. And so it'd be possible that a blind pedestrian could walk out into the street without knowing it. And so for that reason, we put the detectable warning surface, the truncated domes, as kind of a replacement cue to indicate the location of the street. You can see the components of the curb ramp here. We have the curb ramp itself is this triangle in the center, and the street is down here. This whole area where my cursor is the sidewalk or the pedestrian circulation path. So this is the ramp. The grayish area is the detectable warning. At the top of the ramp, we have a level turning space. And since this ramp is within a pedestrian circulation path, we have flared sides. But the flares, as you may have caught on an earlier slide, the flares are not part of the pedestrian access route. They are simply there for the safety of able-bodied pedestrians. And I mentioned the detectable warnings. They provide a visual, meaning a high color contrast cue to low vision pedestrians, and they provide a tactile cue to the blind pedestrian using the cane. And I should note this surface, this truncated dome, is designed to be detected with the cane. But as I don't know that I mentioned it, but low vision pedestrians, the ones who rely on color contrast, they usually don't use a cane. So this surface is also designed to be detectable underfoot. So if someone steps on this, they're aware that they're on that surface. And the rule is use the detectable warning everywhere the curb is missing at a street crossing. And these are used as a warning device. They let the visually impaired know that they are about to enter or cross a street. They do not have any directionality or wayfinding function associated with them. They're strictly a warning device. Curb ramps should be aligned with the crosswalk to help the wheelchair users orient themselves. And on small radius corners, that's fairly easy to do, as you see here. Not so easy on large radius corners. Curb ramp grade, the maximum grade is 8.3%. But again, there's no allowance for construction tolerance. So some agencies design them for 7.1 or 7.5% so that when they're actually built, they won't be steeper than 8.3% or 1 in 12 slope. And when you're chasing grade, the running slope length need not exceed 15 feet, but the slope has to be uniform. Here is the formula for calculating the curb ramp length. And there's a little example here for a 6-inch high curb, 8.3% ramp slope, 2% sidewalk cross slope. If you plug into that formula, you come up with 95.24 inches, almost 96 inches, almost 8 feet for your curb ramp. And then if you think you have to also have a 4 or 5 foot level turning space at the top, from the back of the sidewalk here to the curb, we could be talking 12 or 13 feet. So these curb ramps do take up a considerable length in terms of the sidewalk. We need to be aware of what's called the change of grade or counter slope as someone goes up or down the ramp and encounters the street crown or the crosswalk grade, as we called it. You can see in the upper right there, the footrests of the wheelchair are bottoming out, which is not good, or in the lower left, the chair is maybe about to tip over, which is not good either. Curb ramp width, PROAG minimum, of course, is 4 feet, but the wider the better. So my recommendation is make the curb ramps the full width of the crosswalk or the sidewalk. Turning space. I mentioned there needs to be a level turning space at the top of each ramp. And that is 4 by 4 if it's an unconstrained condition. And notice this ramp, this turning space here serves both ramps, but this is unconstrained, meaning the footrests of the wheelchair could go out over the grass or over this sidewalk as the person is turning. So for an unconstrained condition, it's 4 feet by 4 feet. For a constrained condition, the turning space needs to be 5 feet in the direction of travel. And that's what we're trying to show here. So if this is just grass, for example, next to the sidewalk here, we can use a 4-foot turning space. But if there's a building here or a curb or something that constrains the footrest from going beyond that point, then we need to have 5 feet in the direction of travel. And I mentioned the flared sides. When the ramp is in a pedestrian circulation path, the flares have a slope of 10% maximum measured parallel to the curb. What about if the ramp is not in a pedestrian circulation path? Notice here, this ramp is in the buffer zone or tree lawn, grass strip, whatever we want to call that. And so this is not a pedestrian circulation path. And in that case, we can use the vertical curb return sides on the ramp. Ramp surfaces should be smooth. Texture makes them hard to climb. And it's too bad we're not meeting in person. We could go out on the streets and you could actually go up a curb ramp or go up 2 of them, one that was smooth and one that was textured, to verify this yourself. So I know this may look nice here with the paver blocks, although I don't think they have a big enough turning space at the top. But this is really hard to go up in a manual chair. A better design is to make the ramp and the turning space smooth. Easier for turning, easier for going up the ramp. There are 3 types of sidewalk to street transitions. There's 2 types of curb ramps and something called the blended transition. The first type of curb ramp is the perpendicular ramp. Notice there's 2 ramps per corner. In this case, the ramps are in a sidewalk, so they have flares. There's a turning space at the top. And I think I showed you this image earlier. Again, here's 2 perpendicular ramps at a corner. They both share the same turning space, and that's allowed. The ramp has to be perpendicular to the curb so that both wheels of the wheelchair enter and leave the ramp at the same time, like you see on the left. The image on the right, I still see that from time to time, and it's not good. That's what I'd call a skewed ramp. And notice one of the wheels of that manual chair is off the ground. So this chair is in danger of tipping over because both wheels of the wheelchair are not entering the street at the same time. Second type of curb ramp is the parallel curb ramp, where the sidewalk ramps down to a turning space that's essentially at street level. Notice this slide says minimum 4 by 4 foot turning space at the bottom of the ramp, and that's true for an unconstrained condition, but notice here we have a curb or a little retaining wall at the back of the sidewalk here. That's a constrained condition. The footrest will just bump up against that. And so in this case, this needs to be 5 feet in the direction of travel. So from the back of the curb to this curb here in the back is 5 feet. And notice in this case, the detectable warning is part of the turning space. And these are the cross slope requirements for parallel and perpendicular cross slopes. And notice it's a function of the traffic control on the street that the ramp serves. The third type of sidewalk to street transition is what's called a blended transition. And notice the sidewalk is missing around the entire corner. And because of that, we need detectable warning around the entire corner, wherever the curb is missing at a street crossing. A couple things to remember about blended transitions. The running slope is 5% maximum, not 8.3, and we don't need a turning space at the top for the blended transition. Notice I have not mentioned the single or diagonal curb ramp, where we just have one ramp on the corner. And that's because, notice the second bullet, under PROAG, these are unacceptable in new construction. So we shouldn't be building any more new single or diagonal ramps. They may be okay for alterations if it's technically infeasible to use one of the other types of sidewalk to street transitions. And one of the reasons is, notice this individual in the wheelchair, to get into the ramp, he or she has to leave the protection of the crosswalk, and actually they have their back to traffic just to enter the ramp. Placement of detectable warnings, they should be at the back of curb, and there should be 24 inches of truncated dome material. They do need to contrast visually with the background. Yellow on concrete is fine. In the upper right, you see kind of gray on concrete is not good. I can't even really see the detectable warning here. And of course, probably on concrete, probably black would have the best contrast. But something we've learned from experience is that the guide dogs that assist the visually impaired, the blind, and people with certain low vision conditions perceive that black as a hole in the sidewalk, and the dog will actually lead its handler around that hole. And so now it's recommended that we use any color that provides good visual contrast, but not black. In fact, I think probably the final version of PROAG will say that we shouldn't be using black for the detectable warning surfaces. Quality control is important. NEAT should be measuring the forms, measuring the finished work. Don't just eyeball it. Make sure you or your crews have the proper tools, digital levels, tape measures to make sure things can be measured properly. Any questions on, actually, Mike, if it's okay, we have a few slides left, so let me maybe finish the slides up to make sure we get through, and then we should have time. We can take all the questions at the end if that works.
Sure, okay.
Before we finish, I want to say a little bit about approaches to routing pedestrians through temporary traffic control zones. This is what PROAG says about the alternate route. Notice it also mentions the MUTCD, and basically whenever possible, we should do the work so that pedestrians do not have to detour from the existing route, because if they have to cross a street and then cross it again, that adds distance to the trip. It also makes it more complex and also exposes pedestrians to, of course, conflicts with motor vehicles. I like to talk about sort of the roadway traffic, temporary traffic control zone analogy. You know, on a roadway work zone, of course, there's a number of orange warning signs in advance to let pedestrians or let drivers know what's happening ahead. Same thing with pedestrians. Give them some advance warning of what's going on and let them know what the options are. So when you're talking about or thinking about accommodating pedestrians, think about the type of work that's being performed, the duration of the work. Somebody asked about that earlier, and we'll talk more about that. And then what sort of hazards or impediments will the work create for pedestrians? So here I showed you this activity a little bit earlier. And my sense, well, I wasn't involved in this setup or anything of this project. I was just a tourist in town. But my sense was this was just going to be maybe 1 or 2 or 3 hours sort of activity, a short-term activity. So I say when you have a temporary traffic control zone where the work crews are going to be present for a short time and the work will only last a few hours or less, I would say, figure out ahead of time before you start your work how pedestrians are going to be affected by that work activity. And then establish a plan for how one of the members of that crew will assist any pedestrian, especially those with vision or mobility impairments, in negotiating that work zone. And then identify somebody on the crew to watch for pedestrians and then initiate the plan if the need arises. And I think I mentioned most of the time I was here, there was a crew member sort of standing watch here, both for the fact that there are people below grade here in a confined space, but also looking out for pedestrians, and assisting them to get around this particular closed section of sidewalk. And when you identify that person, it should be somebody who has, the opportunity to look out for pedestrians. For example, if it's a project where you have a flagger in the street, I wouldn't want the flagger to be looking out for pedestrians. Flagging is a full-time job, just watching out for vehicular traffic. But what if the traffic control zone is left in place over several days and we don't have workers present, 24/7? Then we need some more extensive effort to accommodate pedestrians. And remember, they need to be accommodated throughout the entire temporary traffic control zone. So here are some approaches to routing pedestrians. But before I identify those, I want to mention, remember, first and foremost consideration should be safety for all pedestrians. Safety and accessibility are two different things. Just because something is accessible doesn't mean it's safe. We still need to use our training, experience, knowledge to make sure the temporary traffic control is safe as well as accessible. These are the three approaches. We should try to maintain the existing pedestrian pathways if the sidewalk can remain open during construction, but we have to realize, of course, it can't always remain open. Then can we develop an alternative pathway that's parallel to or easily reached from the current pathway? Maybe shift the path, or could we put the traffic into what had been the pedestrian traffic into what had been the parking lane in the street? Or if that doesn't work, then and we have to close the path, can we identify and develop an alternative pathway in advance of the work area where we maybe detour pedestrians to the other side of the street for a block or two and then move them back to the side of the street that they were on originally? And I think we've talked about this. All of these paths that we're talking about need to be accessible. And of course, from the safety standpoint, as I mentioned, make sure we're protecting pedestrians from any trenches or holes or equipment, construction equipment that might be in the area. Make sure that we maintain good sight lines, both for pedestrians and for drivers at intersections. And if you have transit in your area, make sure access to transit stops is provided, and make sure access to business is provided as well. Any questions or comments? I think we have a few minutes left to take questions and comments on anything we've talked about today, or specifically anything since we stopped last time for questions. Mike, any questions come in?
Yes, thanks, Ron. We did have a question from John, who says, does the wood ramp have to have a flat landing in the middle, 5 foot in length, like a regular ramp?
Could you repeat that again? I assume you mean like a temporary curb ramp?
I think so. He says, does the wood ramp have to have a flat landing in the middle, 5 foot in length, like a regular ramp?
I would, if it's a curb ramp, no, and we'll talk about curb ramps Thursday. If it will be some sort of a general sort of ramp, like in the walkway, then you would need to follow that criteria. But for a curb ramp, no.
Okay, thanks, Ron. We'll keep the questions box open for another minute or two. While we're doing that, Ron, do you want to just briefly mention a preview of the things we'll talk about on Thursday for day 2?
Yes, on day 2, we will talk about the specific devices. We'll talk about what's called edging. I think I've mentioned that a few times today. Then we'll talk about channelizing devices and distinguish that from edging. Then we'll also talk just briefly about temporary traffic barriers to make sure everyone's clear on the difference between a temporary traffic barrier, for example, a concrete barrier, compared to a pedestrian channelizer. The pedestrian channelizer is not a crash-worthy roadside feature, meaning if it's struck by a vehicle, it's not intended to protect workers or pedestrians. We'll talk a little bit about temporary ramps. We've had some questions about ramps today. We'll talk about that. We'll also talk about sidewalk closures and how to do that. We'll talk briefly about audible devices, including humans, and then we'll have go through some best practices for handling temporary traffic control zones. And then we'll wrap up with looking at some case studies of actual work sites, and we'll look at kind of the pluses and minuses of each of those.
All right, thanks, Ron. We just had a question from Mitchell, who says the blended transition ramp needs to be 5% or less. Does there need to be a 2% landing anywhere?
Good question. And let me, bear with me, I apologize for backing up like this, but there we go. And this is not the best example, I guess. As the slide says, there's no turning space required. However, what you do also need to consider is kind of independent of the blended transition, I guess. And like I said, this is not the best image, I apologize. But of course, there's a sidewalk here, if you can see my cursor, and then there's a sidewalk here. And it is possible that someone may want to turn from this sidewalk onto this one, or from this sidewalk onto this one, and they're not interested in crossing the street, but they're just turning, making a right angle turn here, either to the left, kind of here on the going from this direction to this sidewalk, or the opposite move, this sidewalk to this one. Remember, those individuals in a wheelchair or with walkers who are making that turn need to have a level turning space to make that turn. So yes, you may need, the short answer is yes, you may need a level turning space here for that movement for people who are not even using the blended transition. So good question, because that is something to think about, that even though they're not using the blended transition or crossing the street, if they're turning, which they very well might be, they need to have a level turning space. And that's the reason I say good question, because that's important to keep in mind. I've seen instances where the designer has kind of forgotten that, or just assumed that no turning space was required, so they could forget about it. But you have to think about all the potential turning movements that might be going on in the area.
Thanks, Ron. Question from Terrence. When will the PROAG become the law?
Good question. I've been saying soon for over 10 years now, and I continue to be wrong, but and don't hold me to this, obviously, I have no role in it, but I have been to 2 meetings this year so far in the couple months of this year, where I have heard officials from the Federal Highway Administration say that they expect by later this year, PROAG will be signed into law. And I don't mean to be cynical, but I'm sort of at the point where I'll believe it when I see it. And someone asked one of the Federal Highway Administration people at one of the sessions I was at, sort of the same comment that I made, that, yeah, we've heard that for years and nothing happened. And this individual said, well, he thought that things were lining up, that everybody was getting ready to approve PROAG later this year. So let's keep our fingers crossed and hope that maybe by the end of the year, we will have a signed final version of PROAG so that it will be the law just like ADAG is.
Thanks, Ron. It looks like we have time for one final question today. This is from Eli. He said, can a cycle track that is right next to a sidewalk be flush, parentheses, at the same grade with no curb? And then he followed up to say, with regard to the cycle track, he's referring to a bike trail paved 10 foot wide, and he says sidewalk 5 foot wide, no separation or grade breaks.
Great question. And there should be, short answer is there needs to be some separation that's detectable, because otherwise the danger is if everything is flush, the blind pedestrian may accidentally sort of wander into the bike area, bike path, and that obviously is not good from a safety standpoint. The issue is that right now in the United States, there is no sort of standard guidance or directional material or way of doing that. But I've made a note, and next time I will add a few slides that show examples of what I'm talking about. So good question, and I'll add some slides for the next class to illustrate what I'm talking about. But yeah, there does need to be some detectable separation between the two, because as I said, otherwise the blind pedestrian can just sort of accidentally wander into the bike path.
All right, well, thanks, Ron. And with that, we will wrap things up for this afternoon. And thanks everybody for your participation today. We appreciate it. And we look forward to part 2 on Thursday.
Yeah, thanks everyone. Have a good day, and we'll see you on Thursday.